Assalamu alaikum students. Once again, I welcome you all to my YouTube video class. This class is a continuation of previous session. In the previous session, we have seen e-commerce security system. In that, we have seen definition of e-commerce security system, various types of e-commerce threats and dimensions of e-commerce security. In today's session, we will be learning about security technologies in e-commerce transaction. What is e-commerce security? E-commerce security is a set of protocols. Protocols is nothing but set of rules that safely guide e-commerce transactions through the internet. Security technologies in e-commerce transaction. Since a large number of confidential informations are involved in e-commerce activities, it must be transmitted through the safe and secure network. Sophisticated security technologies are required to ensure the security of e-commerce transaction. At present, the security technologies in e-commerce transactions are roughly classified into encryption technology, authentication technology and authentication protocols. So these are the three topics we are going to learn today. First one is encryption technology, second one is authentication technology and the third one is authentication protocols. In encryption technology, we will be learning about encryption and decryption and also will be learning about symmetric key encryption and asymmetric key encryption. In authentication technology, we will be learning about digital signature and digital certificates. And the third one, authentication protocols, we will be learning about secure electronic transaction, secure socket layer and 3D secure protocols. So, in encryption, we will see two things. Symmetric key encryption and the another one is asymmetric key encryption, and the second one authentication technology, we will see two things. One is digital signature and the other one is digital certificates, and the last one authentication protocols, we will see three protocols. The first one is secure electronic transaction, and the second one is secure sockets layers, and the third protocol is 3D secure. So these are three main security technologies in e-commerce transaction. First, let us see encryption technology. Encryption technology is an effective information security protection. It is defined as converting a plain text into meaningless cipher text. Suppose I send a message like hi or hello in the sense, it does not pass the same message like hi or hello. Instead, it changes the text into a meaningless cipher text. Cipher text is nothing but meaningless text. That is, encrypted text is a cipher text using different types of encryption algorithm, thus ensuring the confidentiality of data. The encryption or decryption process use a key to encrypt or decrypt the data. So how they encrypt or decrypt the text? Using a key. That we will learn with an example. So it will be easy for you to understand. At present, two encryption technologies are widely used. They are symmetric key encryption system and an asymmetric key encryption system. Look at this picture. This is the sample picture. It shows you what is the encryption and decryption. Both are reverse processes, right? So, encryption is nothing but using a key for plain text and using an algorithm, it is changed into a cipher text. In the receiver side, they receive the cipher text. So, they have to use the same key and also using an algorithm, they convert it into plain text. Okay, so you can understand this with the help of a simple example. look at this picture. Abdul wants to send a message to Rahman. Okay, so Abdul sends a plain text using his laptop or mobile. Okay, and it is encrypted using a secret key, and it is converted into a cipher text. I hope you can see the cipher text here. After encryption, plain text changes into cipher text. It is transferred over the network. So, in receiving side, Rahman gets only the cipher text and it is decrypted to the plain text. Okay, so we will see with the small example for better understanding. Now, look at this algorithm. In this algorithm, the plain text, that is alphabets A to Z, and the secret key is 3. So, once you type A, automatically the A is converted into D. Our secret key is 3, so it shifts 3 characters down. For example, let me type hi. So, when I type hi, instead of H, it will encrypt as K. So, HAI. H will be converted to K and A will be converted into D and I to L. Okay. So, when I type hi, using the key, it will shift each letter 3 characters down. So, the key is commonly shared between the sender and the receiver. So, in the receiver's end, they will get the cipher text. See the arrows in the left side picture. Arrows comes down. In the plain text, we have A to Z and we are doing encryption. Shift key characters down using key 3 algorithm. So, shifting 3 keys down. If you type A, then it will be converted into D in cipher text. So, it will shift 3 alphabets down and send to the receiver. So, this type of conversion is known as cipher text. In the receiving end, the arrows are showing upwards. Here, they are using same type of algorithm but a reverse process. So, this type of process is called decryption. So, D will be converted to A because in decryption, shift key character up using key 3. So, in the sender part and the receiver part, the plain text will be the same, so that the hackers or the interceptors do not identify the message being sent. Even in WhatsApp app message, you will get end-to-end encryption, that your message sent to this number are now encrypted, like this type of messages we have seen in WhatsApp app, right? So that nobody else in between can hack or find what message you are sending it. Now, I hope you understand the concept of secret key. Secret key is nothing but how many characters we are going to shift using algorithm. So, the hackers does not know about it. So, they cannot do anything and they cannot alter it. Okay, look at this picture. This is another example. That is another type of encryption algorithm. The name of the algorithm is mono-alphabetic substitution algorithm. We have plenty of algorithms. This is a simple type of algorithm. Here, if we type A, it will automatically substitute as K. So, they will maintain this table. The concept is substitute top row character with the bottom row character in the sender side. While decrypting in the receiver side, they substitute bottom row character with the top row characters. I hope now you understand about encryption and decryption. Encryption technology is an effective information security protection. It is defined as converting a plain text into meaningless cipher text. So, cipher text is nothing but using some method. It converts original text into some other else, like codes or symbols, which will not be understood by the hackers or interceptors. So, it ensures the confidentiality of the data. The encryptions or decryption process use a key to encrypt or decrypt the data. There are two types of encryption technology. One is symmetric key encryption system and asymmetric key encryption system. Now let us see about symmetric key encryption system. The data encryption standard DES is a symmetric key data encryption method. It was introduced in America in the year 1976 by Federal Information Processing Standard, that is FIPS in US. Okay, DES, that is Data Encryption Standard, is a typical block algorithm. Algorithm is nothing but procedures that takes a string of bits of clear text, that is plain text, into cipher text with a fixed length. So in symmetric key encryption, if the sender sends the message as 5 letters word, then the encrypted message also have 5 letters word in symmetric key. The same length will be maintained in symmetric key encryption method. So in the same way, the decryption will done in a reverse process. Then they will use a series of complicated operations. Just now we have seen some types of simple algorithms, right? But actually they will use such complicated algorithms. Then only the hackers will not hack the information. So through a series of complicated operations, transforms it into another encrypted text of the same length. So in symmetric key encryption, they will maintain a same length. Encrypted data and decrypted data will be in same length. So this is all about symmetric key encryption. So DES, that is Data Encryption Standard, or symmetric key encryption, or more or less same. In symmetric key encryption mode uses 64 bits, but in fact the algorithm uses only 56 bits. The other 8 bits are only used to verify the parity. That is, how many zeros and ones are there. Likewise, they will verify the parity and then it is discarded. So, originally the encrypted code is stored only 56 bits. Balance 8 bits are used to cross-verify the parity. So, just for the safety to make it more and more secure. Okay, I hope you understand this 64 bits, that is split into 56 plus 8 bits. So DES is a typical algorithm that is widely used. Okay, it uses a key to customize the transformation from plain text to cipher text. So that in theory, the algorithm can only be deciphered by people who know the exact key that has been used for encryption. But today it is considered that DES is not safe for many applications, mainly because of its relatively smaller key size, that is 56 bit. Originally we have 64 bits, but in the algorithm uses only 56 bits. So in security purpose, they feel that this size is not enough. So today it is considered that DES is not safe for many applications, mainly because of its relatively smaller key size, that is 56 bits. But the key length can be easily increased by multiple use of the DES. It is described as triple DES. It is otherwise known as TDES, 3DES, or DESETE. The diagrammatic representation of symmetric key encryption. The sender will send a plain text. The plain text gets encrypted and then converted to the cipher text using an encryption algorithm and a key. On reaching the intended receiver, the cipher text gets converted back to plain text using the same key that was applied for encryption and decryption algorithm. The key used can be as easy as a secret number or just a string of letters. So, this is the working method of symmetric key encryption. Now, we will move on to asymmetric or public key encryption. Asymmetric encryption, also called as RSA, that is Reverse-Shamir-Edelman algorithm. The name of the algorithm is RSA, that is Reverse-Shamir-Edelman algorithm. It uses public key authentication and digital signature. So, about digital signature we will see later. It uses public key authentication. Until 1970s, there were only symmetric crypto systems in which the sender and the receiver must have the same key. So, while sending the key itself, the people started to hack the keys. So, there were lot of serious issues. This raised the problem of key exchange and key management. Unlike asymmetric key encryption, the communicating parties need not know others' private key in asymmetric encryption. So, they have two keys. One is private key and the other one is public key. Both the sender and the receiver has a own private key. So, the sender does not know the receiver's private key. In the same way, the receiver does not know the sender's private key. Between them, there will be a common public key. So, each user generates their own key pair, which consists of a private key and a public key. A public key encryption method is a method for converting a plain text with a public key into a ciphertext. So, for converting a plain text into a ciphertext, they will use a public key. But while decrypting again, they have to convert a ciphertext into a plain text, and this time they will use a private key. So, for converting a plain text into ciphertext, for encryption, they will use public key. The same way for decryption, again they have to convert ciphertext into plain text. No, for that time they will use private key. This is the diagrammatic representation of asymmetric key or public key encryption method. Here, the sender will be sending a plain text. For encryption, they will use public key. Now, the plain text is converted into a ciphertext. Then, from the receiver side, again they have to convert a ciphertext into a plain text for decryption. This time, they will use private key. So, they are using two different keys to done this. So, this is all about symmetric and asymmetric key encryption. Now, let us move on to differentiation between symmetric and asymmetric key encryption. The first difference is same key is used for both encryption and decryption. So, in symmetric key encryption, we will use a single key for both encryption and decryption. But in asymmetric encryption, we will use different keys. One is private key and another one is public key. So, different keys are used for encryption and decryption. In the second differentiation, in symmetric key encryption, speed of encryption or decryption is very fast because we are using single key. But in asymmetric key encryption, speed of encryption or decryption is comparatively slow because we are using two different keys. In symmetric key encryption, plain text and ciphertext are of same size. I already said that if we send 5 letters word means, while encryption also we will get the same 5 letters word. Okay, so the same size will be maintained in symmetric key encryption. But in asymmetric key encryption, the size of the ciphertext is always greater than the plain text. So in the concept of asymmetric key encryption, we will not maintain the same length. Okay, the next difference is algorithms like DES, that is Data Encryption Standard, and AES, that is Advanced Encryption Standard, and RC4, that is Reversed Cipher, uses symmetric key encryption. So these three algorithms are using in symmetric key encryption. But in asymmetric key encryption, algorithms like RSA, ECC and DSA uses. So RSA full form is Reversed Shamir-Edelman algorithm, and ECC means elliptic curve cryptography, and DSA full form is digital signature algorithm, use asymmetric key encryption. The next difference is it provides confidentiality. So symmetric key encryption provides confidentiality, but in asymmetric key encryption provides confidentiality, the same way authenticity and non-repudiation. So we are using two keys, so the hacker will not hack the information. It is non-repudiation manner. Okay. The last difference is the number of key used grows exponentially with the number of users. Exponentially means more. It will be goes on. As we said previously, the key length can be easily increased by multiple use of DES, right? Triple DES and all we have learned now. So the key numbers will go exponentially. But in asymmetric key encryption, the number of keys used grows linearly with the number of users. So this is all about the differentiation between symmetric and asymmetric key encryption. So a simple example is given in our book for clear understanding the concept of asymmetric key encryption. Let us see now. In 1976, Whitefield Diffie and Martin E. Hellman devised an algorithm called public key encryption. The algorithm can be understood using color game. This how could A and B get a secret key without letting C finding it out. The trick is based on two facts. So here we have three persons. One is A and another one is B. They are going to exchange the information, but that information without letting C finding it out. Okay. Just look at the picture. A and B has common color, that is yellow color. Okay, that is common public key, that is common for both A and B, and they have a secret color, that is private key. Red color is secret color for A and blue color is secret color for B. So this is a private key. So it is easy to mix two colors together to get a third color. So by mixing yellow color with red color, A get a orange color. The same way, by mixing yellow color with blue color, B gets a green color. Given a mixed color, it's hard to reverse it in order to find the exact original colors. So first A and B agree publicly on a starting color, that is yellow. Now A select a random color red, mix it with yellow and send new color, that is yellow plus red is equal to orange. This information will be sending to B. Similarly, B selects a random color, that is blue color, mix it with yellow and send new color, that is yellow plus blue is equal to green color. This will be sending to A. Now the hacker C may have two new colors, orange and green, but not the A's red or B's blue private colors. So after interchanging the colors, A adds his own private red to B's mixtures green and arrive at a third secret color, that is black. The same way also B adds his own private blue color to A's mixture orange color and arrive at a same third secret color, that is black. So C is unable to have the exact color black since C needs one of the private color to do so. So this is the simple example of asymmetric key encryption. I hope now you understood this symmetric and asymmetric key encryption. The second part of this lesson ends here. The remaining part we will see in the next video class. The assignment of this lesson is difference between symmetric key encryption and asymmetric key encryption. Students, submit your assignment on time. Thank you for watching this video. We will see you in the next video class. Assalamu alaikum.